Hello and welcome to a quick video on creating histograms in Python using matplotlib. So in the previous video, we saw how it's possible to use the time library to measure the runtime of different processes in Python. So in this one, let's use that same library to generate some interesting data we can plot histograms of. So we're going to specify a number of samples and then two empty arrays for storing our measurements. Then we're going to compute the amount of time it takes to square the number pi and store that inside of this array here called square time array. And then we're going to do the same thing for the exponentiation of the number pi and store that in the exp time array, like so. Note that we're using the process time here, which is the actual amount of time that the CPU spends crunching numbers, and not any sort of time it spends being idle doing whatever else. So if we take a million samples and store those, we can also calculate the mean time for these two operations as well as their standard deviation. So it's going to take a while to run here, and we see that the mean time for squaring is around 1 microsecond, and the mean time for exponentiating is around 2 microseconds. But notice that the standard deviation is actually so large that we go beyond zero actually into negative values. So this indicates to us that probably the runtime here is not going to be a nice Gaussian distribution. It's going to be something a bit more exotic. So it'd be nice to plot maybe a histogram that can actually identify and visualize what kind of distribution of runtimes we're dealing with here. So the first thing we can check is if there's any kind of pattern in the runtime versus the run number, like maybe it's sort of decreasing generally over time or increasing. But it doesn't seem like it's any sort of clear pattern right here. We just have very low runtimes most of the time with an occasional very, very large spike here. That's clear both from the linear scale above and the log scale right here. So let us try and make some histograms of the runtime. So first we're gonna have to specify some bins that we're gonna sort of divide the data into. And the way I've done it here is a little bit arbitrary, but I've just specified the minimum value of the square time array, and then the median plus 100 standard deviations as the maximum value. So you have a range from the minimum value to the median plus 100 standard deviations. And again, this is kind of arbitrary, but I found that this kind of works in this case. So whenever you have your own data, you have to specify the bins yourself and play around with them to get a nice representation. So anyway, now we can actually create the histograms. So we're going to specify the figure and axis using PLT subplots. Then we're going to use the hist function here, simply feed it the raw time data, the bins we specified above. We're going to set density to true because we're interested in the probability distribution. All normalized, the area under the curve is going to be equal to 1. Then we set alpha equal to 0.5. Now alpha is simply the transparency of the bins that we end up drawing. And it's kind of nice to have them be sort of semi-transparent because then we can see how sort of multiple distributions sort of overlap and match. Then we do the same thing for the exponentiation time here and plot this on the linear scale, on a log scale, and a double log scale. So let's see how that turns out. Right, so here we have the distribution for the linear scale here. We can see most of the time we have a runtime that's very, very small, but then we have sort of a tail going out here into very small values. It's a bit more evident if we look at the log plot here for the y scale. We can see that we most of the time have a very short runtime, but occasionally we have some very, very long ones right here. And if we actually create a double log plot, we get this sort of almost like linear behavior on the double log plot. And that actually indicates that we have some kind of sort of power scaling going on where maybe the runtime is distributed as like 1 over x squared or something. And we'll investigate that a bit more in an upcoming video. So hopefully this was interesting. Feel free to check out the source code in the description, and I'll see you in the next video. Bye bye.